break. Like, everyone energized with some coffee? Cool. Okay, so today we're going to be talking about visual testing and specifically testing the last mile in our code bases. We're going to be talking about how we can use visual testing to improve the confidence that we have in our software by verifying visual changes to our applications. So this is me. I'm an engineer at ezCater, and I work on front-end things generally. I've worked on our marketplace. I've worked on our design system. And you probably realized at this point that I have an accent. So I'm from the UK, so it saves you guessing. So before we dive into visual testing specifically, I want to take a moment to reflect on what our testing story is like today. And so I'm going to talk about both my experience at ezCater and my experience developing and testing in the wider open source community. So overall, I think we're in a really good place. So there are a lot of good tools for us to use, and they really allow us to focus on what's important, which is, at the end of the day, delivering value to our customers. So as important as testing is, though, there's always this the question of cost versus benefit. For every test that we write in our software, we expect return on investment. So the trick here is that not all levels of testing require the same level of investment. So some of you might be familiar with this testing pyramid. Mike Cohen came up with this concept in his book, Succeeding with Agile. But more recently, Kent C. Dodds has proposed an alternative called the testing trophy. This specific image is from Martin Fowler's website. And the concept and the premise is similar. They indicate kind of where to focus your tests based on the speed of execution and the cost of writing them. So they give you a rough measure of the return on investment. So the shape of the pyramid, or the trophy in Kent's case, indicates a suggested level of investment to maximize return on investment. So for a clearer picture of what that means, I'm going to talk about the types of tools that we use at ezCater for testing at each level of this pyramid. So yeah, this is about the speed and the cost. So at the bottom of this pyramid, we've got TypeScript. We've heard about this a bit today, but the static types in TypeScript help us catch typos. They help us catch type errors. Further up from there, we write unit tests. And these verify individual components on our application, different isolated parts of our systems. And we use Jest as the test runner for our unit tests. Above that, we have high-level integration tests, making sure a variety of components, when combined together, work well. And this is an area where React testing library really shines. It helps us verify that several pieces of our application work when combined with each other. And then at the top level of our tree, we have our end-to-end tests. And this is using a bot to kind of go through and click elements of our UI, interact with our pages to make sure that literally end-to-end our applications work successfully. And at ezCater, we use Cypress tests to do that. So that leads us on to an important question for this talk, is what is visual testing? Well, at its simplest, visual testing is making sure that your app looks as you intend it to do. It's often referred to as visual regression testing. It allows us to compare the current state of our application with a known good state. So it allows us to check that our pages render as expected across different browsers as we make changes to our code. So we're going to go on a bit of a journey today on how we at ezCater got to start using visual testing in our applications. So the first leg of our journey, which is kind of in some level of uncharted territory, is untested visual changes. So I'm going to set the scene about how we ended up with untested visual changes in our code. So we've had a number of people refer to like CSS and JS libraries today. We at ezCater use Emotion. How many people here use CSS and JS? Yeah, that's a good deal of the audience. So CSS and JS, for anyone who doesn't use CSS and JS, it allows us to use JavaScript to style our components. This particular example is from Emotion's doc site. And particularly, I'd like to call out what this piece here is doing. So we've got a container, and depending on the value of our column prop that we pass in, we're actually going to change the flex direction. So we've got some behavior of our application that changes some visual styling based on us changing our props. And for the longest time, we were finding it very hard to write automated tests for this type of code. You can do things like render your component and verify the actual CSS output. And we were finding tests like that to be kind of brittle. So much of our code was then left untested. We try to make ourselves feel a little bit better about this by assuring ourselves that that type of code wasn't going to provide us return on investment. But inevitably, visual errors happen, and they can happen a lot. This particular example was from United. I don't want to pick on them. This happens a lot. The Twitter hashtag at the top, GUI gone wrong, is an example of a bunch of different websites that have these visual problems. And when these types of errors happen, they're not always harmless. Visual bugs can block revenue. So at ezCater, we spend a lot of time doing things like making sure that our call to action buttons are prominent. And doing that kind of work allows us to optimize our conversion rates. Now imagine what would happen then if our styles didn't render that button correctly. We'd end up reducing our number of customers converting, and then that's going to have an impact on our revenue. Going further, you imagine if this dialog had buttons to the right of the text, the user can't interact with those buttons. So those buttons would be unclickable because they're off screen underneath other content. So how can we minimize those types of problems in our application? That's the type of code that we would like to have some test coverage on. This leads us on to the next leg of our journey, which is manual testing. And this is the type of thing that you would typically do as you're developing a component. You're like, I'm going to write this new feature. I'm going to add this new button. I'm just going to do a sanity check to make sure that things still kind of hang together and work as expected. But as our system gets more complicated, that manual verification becomes a lot more rigorous and more complicated, and we end up with potentially long scripts that we have to follow to verify the correctness of our applications, making sure that we still have some level of coverage. And then we quickly realize that manual testing is spending money, and we're only getting one-time feedback. Because automated functional test tools are poorly suited for finding visual bugs, we're shelling out a lot of time on manual tests. So to understand just how time-consuming this can be, we're going to play a little bit of a game. It's game time. So we're going to have a look at a small kids game. You're all going to be familiar with it. Spot the difference. There are going to be 5 differences. So I'd just like you to raise your hand when you've spotted 5. Wow, people are spotting these 5 already. That's great. Cool, okay. So I'm just going to show the rest. These are the 5 differences. So even though this is clearly a kid's game, you'll notice it does still take quite a while to find all the differences. And psychologists have a term for this. There's what psychologists refer to as change blindness. And it's used to describe the tendency that people have to miss changes in their immediate visual environment. So obviously that last example is pretty easy. So we're going to have a look at a more complicated example that has a lot more visual elements. Probably all familiar with this. Over here it's called Where's Waldo? In the UK it's actually called Where's Wally? Well, that's a fun fact. So you can imagine, right, there's a lot more visual elements here to interact with. So it probably takes a lot more time. I'll be surprised if anyone in the audience has found him already, but that's where he's hiding. Spoiler. And you can imagine as the number of visual elements increase, it becomes a lot more difficult. But that's not the only factor at play here. We're developing for the web, so we have this number of different environments that we end up putting our websites out to. Multiple device sizes, multiple operating systems, multiple browsers. So I'm going to do a little bit of math here. So we've got our 5 most popular operating systems. Sorry, Linux, I haven't listed you in this list. But let's take 5. We'll get our 5 most popular browsers. Now, the math is kind of interesting here because not all the browsers work on each of the operating systems. Then we have different device orientations. Again, not all the device orientations are necessarily applicable to each of those environments. But we have 10 mobile device resolutions and 10 desktop resolutions. And the math gets pretty interesting, but you can see there's a number of screen configurations that we want to be able to verify in our applications. So you can imagine trying to manual test through each different configuration for each different change that you're making. It's obviously not going to scale. But there's hope. And the hope is that computers are way better at this than we are. So that leads us on to the next leg of our journey, which is actually snapshot testing. So this was our go-to solution for a good long while. So what is snapshot testing? So we're going to take a look at the jest IO docs. With snapshot testing, values are serialized, stored within text files, and compared using a diff algorithm. So what does a snapshot test look like? Here we're testing a media component. We're asking the media component to render. We're generating a snapshot test. We're finding a button within that component. We're clicking it, and then we're taking another snapshot of that component. When that test runs, if it fails, you might see an output just like this. It gives you a diff of the change that was applied. So this type of test can give you a heads up when you might have made a change that's had an accidental impact and has affected your test environment. You can also use snapshots to verify that the styles that you're rendering in your components have been impacted by a change. And this we found to be a way of getting a heads up that a change that we've made might have a potential impact on how our component looks. Unfortunately, the test itself doesn't really care about what the component looks like, only what the CSS is. Users don't really care if we're using 2 divs for an element or whether we're using 1. It doesn't really matter to our users whether we use tables for layout instead of flexbox. So we were finding that those types of changes were causing breakages when there wasn't actually any visual change on the screen. Also caused some other interesting issues when tests started failing. We go back to our test and we say, well, what was this test meant to do? What is this mysterious snapshot? Where does it come from? What actually should have happened when I clicked that button? So Tomas Gold has a really good article about this. I'd suggest checking it out. It's called Why I Stopped Using Snapshot Testing with Jest. And he says, I call it should render disease. Good tests are meant to act as good documentation. So we had a bunch of other problems with snapshot testing in addition to those. The auto-generated output wasn't at all intention revealing, as we just mentioned, but it was really hard to know why tests failed and how to fix them. There were also a really high number of false positives. And so when we're making changes to our code base, when we're refactoring, the tests would fail often. And refactoring is really where you want your test to be the most reliable. And so overall, this led to a loss of confidence in our test suite and our ability to rely on those tests. Snapshot tests also require a lot of discipline to actually then look at that output that you saw in the diff previously, to scrutinize that output to see what type of change, whether that change was intentional or not. And it was causing us a lot of work at test time. So for a better overview of some other difficulties that come along with snapshot testing, Justin Searles wrote a really good post about that, so I'd suggest checking that out. But that led us on to looking for other options, which leads us to chapter 4 of our journey, which is visual snapshots. So how do visual snapshots work? So we take a screenshot of the UI in a good state. So unlike DOM snapshots, this is literally an image that represents the rendered output of your component. We literally store that image, And then we run the tests again when we make changes to our components. And we compare the screenshots that were generated before and after. And we can then pass or fail the test based on some visual threshold. So I'm going to show you what that might look like. This is an example from American Express has a tool called Just Image Snapshot. This is from their doc site. But this is basically like the computer telling us where Waldo is. So most of the visual regression testing tools that are available today integrate during the CI/CD pipeline, taking screenshots in various different environments, including real mobile devices, and then reporting back these visual regressions. At ezCater, though, we actually favor getting our feedback as early as possible in the development process. We really like having that feedback at dev time when I'm writing the code that's actually causing the test to fail. The sooner I can get that feedback, the sooner I can fix the change and the less cost it has. So I'm actually going to do a live demo now and show you what that looks like today. Can everyone see that? Okay. Cool. So we've got a component here. It's a super important form. We're rendering a couple of fields and a button. I'm just going to actually just save this file now. We're going to run a visual regression test on it. And this generates an image snapshot of that component in its good state. So now you can imagine I come back to this form later on, and I'm like, uh-oh, I've made a mistake. I've done something that's broken my test. This shouldn't really be like this. We get this instant unit test failing, telling me, hey, my snapshot hasn't matched. And so I can actually have a look at that diff output here. And this is telling me immediately where that change was. So it's highlighting the area of the page that's affected. And so I can then trace it back to the code and figure out what's going wrong. I'll try and take some questions after this. Cool. So this has a number of advantages over DOM snapshots. It's much easier to see why tests have failed. And when paired with a git diff, we have a much cleaner picture of why these things have broken. Eliminates all these false positives that we're seeing. So a visual test is only going to fail if there's actually a visual impact on the change that's made. And then we can run these tests in a real browser environment to identify cross-browser issues. So at ezCater, we were thinking, well, this is a really great tool. Let's take this a little bit further. So if good tests are meant to act like good documentation, then why not get a head start on writing those good tests by actually seeding our initial tests from our documentation? So at ezCater, we've got a design system, and its documentation demonstrates the usage of our components. So it shows, here you see a destructive button, disabled state, and a loading state, and it shows the props necessary to render the components in those states. So these exact same conditions make really good test cases to demonstrate that when our application initially renders, it looks like it should. So our documentation site today is actually rendered using Markdown syntax. So on the left, you see the Markdown, and on the right, you see the generated output. So Markdown on the left, and then we use Gatsby to turn that Markdown into an actual website. And so those JSX fence code blocks in our Markdown provide the example syntax and a live playground for trying out that component and playing with it and trying different combinations. That live playground is powered by docz. And so we were thinking, well, wouldn't it be really cool if we could take that same Markdown block that's generating our doc site and use it to kickstart our visual regression tests? So we actually put a tool together for doing just that. There's a GitHub URL there, so you can check that out for yourselves and give it a spin. So when we introduced this change at ezCater into our design system, it allowed us to remove literally thousands of lines of DOM snapshot tests and overall improve the confidence in our test suite without losing any test coverage. Going forwards, our default template for tests, we generate visual snapshots based on the component's documentation. And so this provides us an out-of-the-box regression test coverage, ensuring that a component looks as it should when initially rendered. This saves us a whole bunch of time and money because now when we're authoring our tests, we only need to test that a component behaves as it should. So that's the number of lines we ended up removing. And here's us saving lots of money. So what challenges might we come across when implementing this for ourselves? So the first thing we bumped into was animations. Now, animations are really great for enhancing our applications, but you can imagine they kind of play havoc with taking snapshots of our application in different conditions. The timing of the taking of the snapshot will change, or the timing of the progress through the animation will change based on when you take a snapshot. So our initial solution at ezCater for working around that was to disable animations in our test suites to make sure our snapshots are taken in a consistent state. So here we can see that we're setting the transition property to none, animation to none, and this is literally just in our test environment. You can also do other things like tell the animation how far it should be through and pause the animation so that you can make sure that you're verifying the animation in a consistent state. The next challenge that we had was that operating systems render content differently. So you can imagine I'm authoring these tests on my Mac here, and then I send it up to CI, and the CI environment just happens to run on a Linux platform. And when it takes its screenshot, the anti-aliasing techniques that are used by that environment when rendering a component vary from what was used in the seed environment. So that can break these visual snapshot changes. So how do we work around this? There are a number of different options available to us. So the first one I'll mention is Docker. Docker allows, how many people are familiar with Docker? Cool, a great number of you. So Docker allows us to host a different environment within the current operating system. There's also a plugin for Jest called Jest Puppeteer Docker, which was created by Smooth Code, and it allows us to run our tests in a standardized environment in Jest so that we can run our tests in a standardized way. Yeah, which is really cool. Another approach that we use at ezCater is to run our tests in Puppeteer inside of an AWS Lambda. Again, that's another way of like normalizing the environment in which the snapshot is generated. So if you're interested, though, in rendering across different operating systems environment and environments on different physical devices, you can also use APIs like Browser Stack. They've got a screenshot API for generating these screenshots. So you can use a service like that to take screenshots in various different environments on real devices so that you can verify the output of your tests. So the next issue that we had is that some of your tests might contain dynamic content. So this is from Amazon, and the box up here might be an ad, and it will change depending on me reloading the page. So this is actually a problem that we don't typically get in our design system at ezCater because we have full control over the props that are passed into our components. Components that use static data are a lot easier to test and verify than components or pages like this with dynamically changing data. I'd also recommend generally when snapshotting a page like this, you keep the snapshots as small as possible. So break this page up into smaller pieces and make it a little bit easier to reason about. That being said, let's look at a few ways that we can solve this problem. So the first one I'm going to mention today is Jest. Jest has some mocking tools, and that's going to allow us to replace dynamic content in our components with static content that we know ahead of time. There's a cost associated with that, and that's the mocking requires us to do some upfront switching out of that dynamic content with a static resource. So it's going to require us to do a bit more setup in our tests. Another possibility to solving this problem is to use better tools. So this example here is from Applitools. And tools like this one allow you to actually mark specific regions on a snapshot and either ignore it entirely or use more advanced matching techniques. So many of these tools have capabilities to overlook common environment normalization issues like text anti-aliasing, so that your tests only break for the differences that are actually meaningful to you. So what does the future of visual testing look like? The algorithms that we use to detect changes are really improving. So computer vision technology, which is what powers self-driving cars today, allows them to recognize objects that can be used to power our snapshots. You can imagine this literally applying that same technology for this. These processes can also then be used to power AI-assisted bug diagnosis. So instead of using the git diff to look at your lines of DOM and your CSS rules, we can use tools such as this to automatically track which areas of the DOM and CSS have changed and caused the specific difference, to just speed up that bug fix process. So what are the main takeaways today? The main takeaways are that visual testing is the process of making sure that your app looks as it was intended to look. Visual bugs aren't just cosmetic. They really cost us money. So it's super important that we have these tests. Visual testing can be a great addition to your testing strategy today. Thank you.